Hi, I'm Barış Salihoğlu. I'm the coordinator of Bridge Black Sea project, and also I'm the director of Middle East Technical University Institute of Marine Sciences. And today I will be talking about the digital twin ocean demonstrator that we have developed as part of the Bridge Black Sea project. And today, in around about 15 minutes, I will try to summarize the digital twin ocean of the Black Sea. But before, I would like to tell you about the importance of the seas and oceans and the uniqueness of the Black Sea system. And then I will give a brief introduction about what digital twins are, how they can be used. And after a small overview, a short overview of Bridge Black Sea project, then I will tell the details of the digital twin ocean demonstrator and how it supports policy and decision support in the Black Sea. As most of you may already know, world oceans provide many services to us. And among these services, there are very critical ones. For example, the oxygen that we breathe, it comes from the oceans. And without the oceans, the planet Earth would not be habitable because the carbon dioxide levels would be very high. And oceans store more than 50 times of carbon dioxide than the atmosphere can store, and it absorbs 25% of all the human-based emissions. And beyond these, oceans play a very critical role in terms of climate regulation, and it plays a very strong role in terms of storing the heat content that's part of Earth's climate system. And beyond these, we also benefit directly from the oceans. For example, we utilize the oceans to produce medicine, and we also exploit the oceans for seafood. When we look at the oceans, certain sectors depend mainly on the oceans. Among these sectors are tourism and transportation. For example, when we look at tourism, almost half of it is dependent on the seas and the oceans. And most of the transportation goes through the oceans. And when we look at the economic value of it, out of 17 trillion, $10 trillion is conducted through the seas. Same with food. The oceans doesn't only provide us economic value, but they also provide employment to humans. And around 3.3 million people, they are dependent on the oceans in terms of the oceans providing food. I mentioned about medicine, climate regulation, but another strong service is blue carbon, the carbon dioxide that the ocean ecosystems store. And oceans inhabit a strong biodiversity. And there are certain emerging sectors that are growing very, very fast. And among these are ocean energy and biotechnology. Although we are highly dependent on the oceans, both in terms of economic value and job security, oceans are suffering under many different stressors. And among these stressors are climate change, deoxygenation, acidification, overfishing, invasive species, and pollution, and many activities that are conducted by different sectors. And to better manage the oceans and the ecosystem services that the oceans and the seas provide to us, we need to better understand the ecosystems and the habitats of these seas. And we need to do this together with the society, and we need to benefit from new technologies while providing options for policymakers. And Black Sea is also among one of these seas that has suffered under many different multi-stressors. And when we look at the Black Sea, its unique comes from these many different stressors that are acting on it. For example, Black Sea is mostly deoxygenated, beyond under 100 meters, it's anoxic. And on top of this, the pollution pressure continues on the Black Sea, and because of overfishing invasive species, the effect of climate change, we have seen regime shifts in the Black Sea. So when we combine all these different effects, Black Sea is very unique, and Black Sea also possesses a very high biodiversity and provides many different ecosystem services. But we need to understand how these stressors are acting on the ecosystem and the services, and how we can provide solutions both for the ecosystem and sustainable solutions for different sectors. And digital twins are very useful tools to help make decisions, and they are being utilized as decision support tools already in engineering, already in city planning and architecture. However, more and more scientists are starting to utilize digital twins for earth sciences. And we oceanographers, we are also developing digital twins for the oceans as decision support tools. And Bridge Black Sea project is one of the strongest projects that's contributing to a digital twin ocean in the Black Sea. The main aim of Bridge Black Sea project is to develop blue growth solutions towards resilience ecosystems. To achieve that, we have defined a safe operating space for the Black Sea, and the safe operating space supports blue growth pathways under these many different stressors that I have been talking about. And the Bridge project is structured under 3 nodes. Under the first node, we have developed the models that we use in the digital twin oceans, and we have developed many different tools that are part of the digital twin ocean that I will be talking about. But these are not developed in isolation, but it was a true co-development framework, and we were in touch with many different actors, and we have benefited from their inputs, and we did that while we are empowering the citizens of the Black Sea. And if you go on the webpage of the Bridge Black Sea project, there you can find certain results. And among these results are the defined key multiple stressors for each pilot area of the Bridge project, as well as at the basin scale site. And beyond that, we have also defined key ecosystem services that these different multi-stressors are affecting. If we look at how the Bridge Black Sea project is structured and how it's supporting the digital twin ocean demonstrator, you will see that under the first node, there is the knowledge base. And there we have the Bridge database, we have the Blue Economy observatories, and there we have developed different scenarios that are tested by these models. And to test the safe operating space in the Black Sea, we need many different compartments. There's no one tool to address the safe operating space. So with the safe operating space, we have aimed to define the planetary boundaries for the Black Sea. To do that, we have benefited from an ensemble of models. We did the resilience assessment in the Black Sea for the first time, risk-based cumulative effect assessments, both at the pilot scale and at the basin scale. And we have developed an AI-based emulator that we are utilizing as a decision support tool. And these all have merged under the Black Sea Digital Twin Demonstrator. Of course, Black Sea bridge project and the digital twin ocean demonstrator, as I have mentioned, has highly benefited from the multi-actor efforts that we have conducted under the project. For example, we have established living labs, and we did 4 rounds of living labs where we have collected socio-economic data, and then we have also provided knowledge to many different stakeholders. And under Bridge, we had the Black Sea Accelerator program, as well as 2 high-tech summits. And empowering citizens and also awareness and education was a very strong part of Bridge. And understanding the seas, but also better digital twin ocean demonstrators with lower uncertainty, we need to better understand the sea and its ecosystems. And to achieve that, we have developed many different monitoring tools during the Bridge Black Sea project, and we hope to continue these efforts with our partners beyond the Bridge project. Digital twins of the oceans are really a game changer for the oceans. It's quite ambitious because the main reason why it's so ambitious for the oceans is that we do not have as much data as engineering practices, for example. But for an application to be a digital twin, at the minimum, we need virtual interactions between physical, chemical, and biological properties, and these should be demonstrated with this digital ocean demonstrators. And they need to benefit from data sources, data lakes, and data and observations. They need to be supported with AI-driven data analysis, but also AI-driven lightweight tools, so we can utilize these digital twin oceans on demand by different actors. And interoperability and standardization of the outputs is also critical. But these digital oceans should be able to test different what-if scenarios for decision-making. And under the Bridge Black Sea DTO demonstrator, we have these scenarios. For example, we are testing different climate change scenarios, different fisheries scenarios, plastic, and pollution. And we have also tested the desired scenarios that are developed as part of the Bridge project. And these all are serving towards a safe operating space in the Black Sea, but with strong links to ecosystem services and also different policy frameworks such as marine spatial planning and MSFD. And now Bridge Black Sea Demonstrator is on the editor system. So you can go and directly access through the editor system, or you can go to Bridge Black Sea web page and access directly through there. And what you will see there is that the Bridge Digital Twin Demonstrator is also supported by the DecoSim project, and we are aiming to continue to sustain this digital twin ocean demonstrator as part of the DecoSim project. And when you go on the page of the digital twin demonstrator, this is what you see. You will see different compartments here. And the first compartment is on exploring physics and biogeochemistry, and you can access many different options there in terms of physics, the circulation fields, temperature, salinity, but also almost all the compartments of biogeochemistry, and you can compare these under different scenarios, for example, under different climate scenarios. Same with fish. You can pick whatever species of fish you wish to see, how they change under different conditions, and same with plastics. And now on the left, you see how different scenarios are being compared. And risk-based cumulative effect assessment is done both at pilot scale and at the Bayesian scale, and same with resilience assessment. You can see the results of the resilience assessment, and you can see how AI-based emulator is functioning. And this is how the overall portal looks, and it's very easy to use. You don't need to have a certain education, but you will find on the portal certain definitions that will help you understand what these different fields are and what different scenarios are. So please go ahead and visit the Black Sea Digital Twin Ocean. It's one of the, I think it's the only digital twin ocean demonstrator on the METU system. And it was also highlighted at the recent DigitalOcean forum. So with this, at the end of my my lecture, I would like to mention about a few take-home messages. So under the Bridge Black Sea project, we have developed the first DigitalOcean demonstrator for the Black Sea. We believe it's really pioneering work with many different applications that we have developed here. Also, the other basins are benefiting from the design that we made. And it was a truly co-designed process with stakeholders. We have definitely considered stakeholder input while we are developing different scenarios. And it addresses different ecosystem services that I have mentioned to you, and it links these ecosystem services to marine strategy, marine spatial planning, and marine strategy framework indicators. And it includes a resilience and assessment for holistic assessment of the safe operating space. And it incorporates these diverse components. Of course, there is an open area to better understand the safe operating space, but we have included, I think, the main components that can be utilized to better understand the planetary boundaries. And this DTO serves as a blueprint for advancing DTOs towards decision support tools. And it's developed as an editor-ready architecture. And it has connections with key data infrastructures, for example, EmoteNet, CDataNet, and Copernicus. And on the portal, you can also access DECOSYM web portal and DECOSYM database, and you can see the data that DECOSYM can provide to you. With this, I would like to thank you all.